A major question that we have to ask ourselves at some point in time when we get going in mathematics is why do we manipulate equations? So if we look at these three here, all three of these equations are actually representing the same hyperbola. So why might we want to look at this in three different ways? That's a great question. Um, you know, if one way were just a way to look at it and we could see everything, then there would be no need to. But I'll go through three examples. So let's say we're given this equation, and the directions are to find the hyperbola's center, vertices, foci, asymptotes, x and y radius, and to graph it. We could do some of that from this equation, but it's a whole lot easier to find all of these things by dividing through by 144 and getting x squared minus 36 minus y squared over 16 equals 1. Because we know that the x radius would then be 6, the y radius would then be 4. We know that the center is 0, 0, but we kind of knew that already because we didn't have to complete the square. We know that the vertices, since the x is positive, would be at 6, 0, and negative 6, 0. And we know that the foci, we know that they're on the outside in a hyperbola, so they would be at plus or minus the square root of 52 comma 0, because we would take a squared plus b squared to get where the foci are. We have y minus 0 equals plus or minus 2/3 x minus 0, or y equals plus or minus 2/3 x. So we can quickly get everything if we manipulate it into our graphable form. But if I'm given a different question, if I'm given different directions, I might not want to manipulate it in the same way. So if I have to find the intersection of this hyperbola with this ellipse, well, I could get both of these into graphable form and at least get a picture of it. But notice that I have a minus 9y and a plus 9y. And so if I'm trying to find the intersection, I know that intersection means system of equations. And if I'm trying to find the intersection of this, then it might be more beneficial to just leave this the way it is. If I have 4x squared minus 9y squared equals 144, and 2x squared plus 9y squared equals 150, I can just solve by elimination. I get 6x squared equals 294. I divide through by 6. I get x squared equals 49. So x equals plus or minus 7. So my intersection points would be at plus or minus 7 square root of 52 over 3 and plus or minus 7 negative root 52 over 3. And if I double check that, I would find that there were 4 intersection points in this problem. So in this case, it would be good to not even manipulate it at all. But then I have a third case where what if I find the intersection of this with this equation? Well, I could multiply this through by 9. I could um, get a lot of different things going on here. But notice that in this equation, if I look at it, I have a 4 here and I have a 9 here. So normally, if I wanted to graph this, I would divide by 144, like I did here, in order to make this equal to 1. But my directions are different. I want to find the intersection with x squared over 9. And so in that case, it might actually be beneficial to divide everything by 36. Notice that I don't really get any nasty numbers over here. I end up with x squared over 9 minus y squared over 4 equals 4. So yeah, I still have a fraction, but it's not that horrible because if I divide by 36, I get 4 plus y squared over 4 on this side of the equation if I add this over, and then I can just make a substitution. So now I have 4 plus y squared over 4 equals y plus 6 squared minus 32. That equals 0. So y equals 0 and y equals -16 are my answers. And when y equals 0, x equals plus or minus 6. So I have plus or minus 6 comma 0x. So it's something that's not very nice, but it's plus or minus 24.739 or so. But in any case, we have something -16. So we have plus or minus something and then -16. But we end up figuring out what to do. So basically, the conclusion is sometimes a different way of looking at the same thing is actually more beneficial. These are all the exact same equation, they're just written in different ways. And given the directions, you may find a benefit to doing one or more different ways of looking at it.